All right, so this lesson is solving linear systems by substitution. It's lesson 11.2. EQ, how can you solve a system of linear equations by using substitution? And so the learning goal for today is I can determine the solution to a system of linear equations by using substitution. All right, and so this is just right out of the textbook. The substitution method is used to solve a system of equations by solving an equation for one variable and then substituting the resulting expression into the other equation. Okay, so the steps for it are shown here. There's 3 steps. Step 1, you solve one of the equations for one of its variables, and you have the option to choose either equation, because remember, when we're dealing with systems of linear equations, we have 2 equations and we have 2 variables that they contain. So you're going to pick one equation, whatever one looks like it's easier to work with, or if one of them is already solved for one of the variables, which means x or y is by itself on one side of the equal sign. And then step 2, substitute the expression from step 1 into the other equation, okay, the one you didn't pick, and then you're going to solve for the other variable. And then the last step is to substitute the value from the last step into either original equation and solve to find the value of the other variable. So whenever we solve a system of equations, if you guys remember, we're looking for an ordered pair that represents the solution. If there is one solution, it's an x value and a y value. So if we're graphing it, we saw that that looked like where 2 lines would intersect at. That was their point of intersection. If they intersected everywhere, then there was an infinite amount of solutions. If they were parallel lines, there was no solution at all. And so let's look at an example. Okay, so we're going to solve this system using substitution. And so this is a system of linear equations. There's 2 equations. And the first equation, 3x plus y equals -3, has x and y. The second equation, -2x plus y equals 7, has x and y in it, okay? Same 2 variables, 2 equations. So I got to find values of x and y that make both equations true. And so we're going to use the substitution method. And the first step of that method, solve one of the equations for one of its variables. And so we're going to do that. Solve an equation for one variable. So if we just select one of the equations, they're both pretty easy to work with, but we're just going to pick this first equation, and we're going to isolate y, because it's easier to get y by itself than it would be to get x by itself, because the coefficient on your y term is 1. So we just subtract 3x from both sides, and that's why it turns into y equals -3x minus 3. That's the first step. Step 2 is the substitution step. We're going to substitute the expression we got. So the expression we got is -3x minus 3. We're going to put that in place of the y in the other equation. So the other equation, -2x plus y equals 7. Writing that out, -2x plus y equals 7. But instead of writing y, I'm going to put the thing that we figured out y is equal to in the first step. Y equals -3x minus 3. So this is the substitution step. You're replacing the y with this expression. Then we're going to solve this. Okay, so these parentheses are here because I substituted, but they're not really doing anything besides just showing me where I replaced y. So this term, -2x, and this term, -3x, we're going to add them, which gives us -5x. And then -3 and 7 are like terms, so we're going to add 3 to both sides. That's where 10 comes from. 7 plus 3 is 10. And then -5x equals 10. -5 times x equals 10, so divide both sides by -5. X equals 10 divided by -5 is -2. Okay, so at this point right now, we have now solved for x. We know what x is, but we need to now find out what y is. All right, so what we're going to do then is substitute the value that we found for x into one of the equations and solve for y. It doesn't matter which of these two equations you choose. Okay, just pick one. And we're just going to pick this top one, 3x plus y equals -3. And then instead of x, though, I'm going to write this out. I'm going to put what we know x is equal to, which is -2. So we put a -2 here, and then solve for y. We multiply 3 and -2 together. That gives us -6 plus y equals -3. To solve for y now, we're going to add 6 to both sides. -3 plus 6 is +3, so y equals 3. And so at this point, I now know what x is and I know what y is. Whenever you do one of these problems, you do want to check your work. And so this last slide here, not last slide, sorry, but the last part of this problem, if x is -2 and y is 3, that's our solution. So if I graph these two lines, they should intersect here. Another way I could check is by plugging in the values to the two equations to see if, no, that's not what they did. They found intercepts, okay, to graph it. But here, I do want to open up Desmos right now and show you guys how to use Desmos, and I think you're going to really like it, especially if you're struggling with graphing, because it's a really good tool to use to graph. So, my mouse is freezing on me. I need new batteries in it. I'm going to come right here to our week at a glance. And so just so you guys know, we have websites that we use all the time on here. Okay, and so they'll just pop up. And so if I open this, websites we use, Desmos. I'm going to go desmos.com. Okay, and when you go to the site, this is the graphing calculator. Okay, and so the link that I shared with you on the week at glance will take you here directly. If you just type in Desmos and go to the website like this, you'd come up to a page like this. So if you want to get to the graphing calculator, you just have to click graphing calculator. And so you can type in an equation like y equals 2x plus 5, and it graphs it for you. If you wanted to have two equations, y equals -3x minus 8, it'll do another equation for you in another color. Notice that the red matches up with the red line, and the blue matches up with the blue line. So if I was trying to solve a system of equations and these were the two equations that I wanted to solve, I could use Desmos and then look to see if there's a point of intersection, and you can zoom in. You can just click and drag it. So it looks like they intersect right here. And if you click on it, it'll actually give you an ordered pair that would represent your solution. So we're going to use Desmos right now to check our work from the pair deck. Okay, and so the equations we have here, 3x plus y equals -3, -2x plus y equals 7. And there's a picture here showing its graph. I just want to show you that you can and should use Desmos to help you do your work accurately. And so I'm going to go ahead and type those two equations in. Okay. So here I am, I'm on Desmos. I've typed in both equations. These two lines, I don't see where they intersect at this point in time, but they don't look parallel, so I'm thinking they intersect somewhere up here. So what I'm going to do is just kind of drag until I get closer to it, and you can zoom in to be even closer. And then if you click right where it's at, it's going to pop up the ordered pair. So those two lines intersect at the ordered pair -2, +3. And that's exactly what we had in our pair deck. Okay, -2, +3. So this is an example of substitution where there's one solution. But just like with any system, you can sometimes have infinitely many solutions or no solution at all. And so if I'm using substitution, what does that look like? Well, here's a system of equations. -3x + y = 12, 6x - 2y = 18. And if I go through the steps of substitution, which is to rewrite one of your equations, so it's solved for one of the variables. So I could take this top equation and just add 3x to both sides, so I get y = 3x + 12. Since this is solved for y, I write out the second equation, but when I get to the y, I don't actually put y there, I put what y is equal to from step 1. Okay, so that's why we get 6x - 2 times the quantity of 3x + 12. So we're taking this whole amount here, this expression, and substituting it into the parentheses. And then to solve this equation, you have the distributive property. We have to take care of that. And so when you do distribute and simplify this side, you end up with your x term canceling out, and now you're left with -24 = 18. So if you end up with some nonsense statement like this, then that is an indication that there is no solution to the system of linear equations. Here's another system of linear equations. -2x + 14y = -28, x - 7y = 14. And so if we go through our steps again, choose one of these two equations. Looking at these, there's a coefficient in front of the x and the y in the first equation. For the second equation, x has a coefficient of 1. So this is a better equation to choose to isolate the x, and that's why they did that, x. And then we add 7y to both sides of the equation. X is equal to 7y + 14. And then you do the substitution step, which is to write out the first equation. And then when you get to what x is, though, the x, you're not going to write x. You're going to instead put the expression, what x is equal to, 7y + 14. And then using the distributive property and simplifying the left-hand side, your y term, again, the variable gets canceled out. And in this case, we end up with something where it's a number equal to a different number. So -28 equals -28. On the last one, two different numbers means no solution. If you get a number equal to itself, then that tells you there are infinitely many solutions. And that's what the solution is. You actually write that out. Okay, and so again, this is just the steps, a little more detailed than I gave you at the beginning of the lesson. So to solve a system of equations by substitution, you're going to first solve for one variable in one equation, then substitute the resulting expression into the other equation, solve that equation to get the value of the other variable, substitute that value into one of the original equations and solve, and then write the values from step 3 and 4 in an ordered pair. You want to check your work either by substituting into both equations or by graphing. Now, like I said, this is something usually you guys get in 8th grade a little bit. So it's the first time seeing this. And it is confusing at first because it's something that's new. And just my experience with students when they learn these 3 different methods, students typically don't really care for this method. I think it's because it's a lot of algebra. So I'm going to teach you all 3 methods. We've already learned graphing. This is substitution. And there's going to be one more method we learn called elimination. You can use any method to solve a system. So sometimes it'll be easier to use one method or the other, but you can use any method to get the answer that you're looking for. So if you find a way that you understand how to solve a system, if it's by graphing, because I just showed you on Desmos how you would just type in your equations to see where they intersect. If it's substitution, or if it's the new method we haven't learned yet, elimination, you can use any of the three methods to solve any of the problems that you may get. Okay.